Hello everyone. In this tutorial, you can learn how to make text animation similar to the music video Pump by Valentino Khan. I made this with geometry nodes. As you can see, we can change multiple variables which are based on physics. With these variables, we can modulate bounce intensity, bounce interval, damping rate of the bouncing wave. Let's get this tutorial started. First, we have to download Blender version 4.0 alpha in order to use the newly introduced repeat zone. For those who don't want to use version 4.0, I made another version which used duplicate elements node instead of repeat zone. It's gonna be available in the following tutorial. However, I strongly recommend you to learn how to use repeat zone in this tutorial. Someone might wonder why I don't use the simulation zone for this tutorial. Simply, it is too slow with simulation zone, also it needs baking. Yeah, not convenient. This is the reason why I started with the repeat zone. Let's make text instance, and apply shaders on main surface and rim, respectively. As you can see, in the original music video, the side of rim is darker than the front of rim, which is white. This could be achieved by changing the direction of light, but I've simply applied a rim shader, and I'm gonna tilt the text instance in order to make a darker side. Let's add a camera. It's time to add a repeat zone. The core idea of this tutorial is as follows. First, duplicate text instances by the number of frames which make the bounce trajectory, using repeat zone. Then, set the scale to 0 to hide them, and at the appropriate timing, increase the scale to 1 to sequentially reveal them. Don't forget to apply a geometry 2 instance node in the tail of text settings. In a repeat zone, we can store attributes like the position vector and velocity vector of an instance of certain frame. By using store named attribute node, we can access those attributes in the next iteration by using named attribute node. And based on those attributes, we can calculate the next vector for an instance of the next frame. And it's very important to change the domain to instance in the store named attribute node, because we are now treating text instances. By dividing the initial velocity vector by FPS, each component of the vector will be treated as a value with units of meters per frame. We can copy and paste the custom FPS value as a new driver. It is very convenient, in that the input FPS of the geometry nodes is automatically synchronized with the custom FPS. Yes, we don't need to change FPS 2 times. The initial physical attributes are set up. It's time to make a logic to calculate the next physical state with named attribute nodes. This logic is very simple. Just add acceleration, in this case gravity, to previous velocity, and add the newly calculated velocity to the previous position. It's important to divide gravity by the power of FPS, because the calculation is based on frame unit. The reason for prefixing the name with precalculated is that those values will be updated later to account for bounces. For now, just apply these values to the repeat zone without considering bounces. It is very important to follow this step without confusing the order of nodes. Now we're going to accumulate text instances. Well done, repeat logic works as expected. Let's change the initial physical states. Whoa, we need a minus value like real-world gravity. Before we apply the bounce logic, I'm going to show you how to implement the sequential visibility controller, which is the core part of this text trajectory animation. it's simple if-else logic, in which a text instance is visible when its index is less than current frame minus the start frame. This means that as time progresses, higher index instances are becoming visible. Wow, it works! In the original music video, text trajectory remains unchanged. But, I want to introduce fade-away effect on them. Fade-away effect, disappearing effect, or tailing effect, call that what you will. Next, let's finish the physics calculation block by applying bounce conditions. The bounce condition is that, if the y component of position vector is less than 0, it is treated as bounced from the ground. And, when the bounce condition is satisfied, the y component of position vector should be replaced to 0. For this replacement, we're going to multiply the original position vector by 101 vector. Considering real world, at this frame, the instance should be bounced off from the ground. We can compensate this error by applying theoretical bounce speed to the y component of velocity vector in the later part of this tutorial. For now, let's just make a reflection on the y component of velocity. Nice, bounce logic is applied well. It's time to apply the theoretical bounce speed to the y component of velocity vector. Because this is a motion of constant acceleration, we can calculate the velocity just before the collision to the ground, using this equation. I think there is no need to show all the nodes building for this equation, so I just capture the final node setup. We've almost set up the physics nodes, the remaining task is only to apply damping. As you know, the maximum bounce height gradually decreased with each bounce. I just call this damping. We're going to increase the bounce count when the bounce condition is satisfied, and save the count number using a store-named attribute node. Like this. Wow, it works as it is expected. The physics node setup is just done. As you can see, in the original music video, the side of rim is darker than the front of rim, which is white. In the initial part of this tutorial, we applied black color to the side rim. To show the side rim a bit more, we are going to tilt the text instances along the y-axis. Nice. We've just finished node building, congratulations. The remaining parts are the camera setup and the evaluation of the overall calculation time of this node setup. Before starting the remaining, let's change the initial physical states, gravity, and other variables to check this node setup works as expected. Because we need the projected 2D image of this scene, we can do this by changing lens type from perspective to orthographic. With a higher FPS, we can get more denser stack of text instances. Oh! We can change the text font in the string to curve node. Good! We've just built up the node configuration with repeat zone, which is newly provided from Blender version 4.0 alpha. In this node configuration is based on real-world like physical motion of constant acceleration. And it looks good. However, this computation speed of this node setups is a little bit slow. For example, in my computer, when the frame counts are 500, the computation time is about 55 milliseconds. But the time of the computation abruptly increased to 2000 milliseconds when frame is 5000. So I'm gonna upload the part 2 of this tutorial, in which I use the duplicate elements node, instead of repeat zone, and this new node setups is much more faster than repeat zone. So, meet me at the part 2 and thank you for watching this part 1.